Okay, so properties of quadratic functions. We're going to focus on just two. We're going to focus on the standard form and the vertex form. To be quite honest, I don't even remember doing the intercept form, even when I was in school. So unless I had some more information on that one, I don't even know if I could give it to you accurately. All right, the graph of a quadratic function is called a parabola. If a is greater than 0, it's going to open up. So obviously you have your xy axis, and apparently I don't have a pen that works. So you have your xy axis. You have one that opens up. And then this is when a is greater than 0, so your a is going to be positive. And then you're going to have this point right here, which is your vertex. And then if your a is less than 0, you're going to have a graph that opens downward. And that point is still your vertex. So this is when a is less than 0, so it's negative. So if it's positive, it's smiling. If it's negative, it's frowning. The lowest or highest point on your parabola is the vertex. So if it's opening up, you have a low point. If it's opening down, you have a high point. The line that goes through the vertex is your axis of symmetry. So this is your axis of symmetry. And it will be x equals some number. And that some number is the x value of your vertex, which we'll get more into that. So that's pretty much all the parts there. So if you look at this picture, I'm going to enlarge this just a little bit. Everything's labeled here. Okay, you have your axis of symmetry. So remember, this is going to be x equals some number. It's the x value of your vertex. You have your x-intercepts here. And if you recall from your Algebra 1, the rocks. So your roots, your zeros, your x-intercepts, your solutions. So this is your y will be 0, or f of x is 0. So your points will be some number x and 0. And there will normally be 2 of them because it's quadratic and it's crossing the x-axis twice, unless it's one of those perfect square kind of things, and then it just lightly touches the x-intercepts. You've got your y-intercept over here. So this is when x is 0. So it will be 0 some number y. And then your vertex, this is your maximum or your minimum, depending on if you're opening up or down. So all of those are the parts we're going to be looking at today. So starting with standard form. So to find the vertex in standard form, so you know when you have the equation of line y equals mx plus b, you can look at it and you see the slope is m and the y-intercept is b. When it's in standard form, you have to do a little bit of math before you can get the slope, right? Same thing here. When you're in standard form, to find the vertex, it's negative b over 2a, and then your y value is the function of negative b over 2a. So once you've plugged it in, okay? And then your axis of symmetry is the x value of your vertex. And then this one is a little bit easier, I think. If you're in vertex form, it's very similar to that equation of the circle. Remember how we had x minus h squared plus y minus k squared, and our center was h and k? Well, if you look here, you've got that h and that k again. where h is the x value of your vertex and k is the y value of your vertex. So keep in mind, remember to change the sign. So here, remember, change the sign. So change the sign of h. So if this said x minus 3, then the x value would be positive 3. If it said x plus 3, the x value would be negative 3. So you always change it. Remember, whenever you're inside those parentheses, things are always opposite. They get wonky. And then, of course, your axis of symmetry is still the x value of your vertex. Okay? All right, so now go to the first example, which is the white page in the notes, the ones that got crazy. So it will say example 1 at the top. So example 1 is starting out with a vertex form. All right, so we're going to start out with a vertex form. So think about f of x equals a times x minus h squared plus k. So if I'm looking at this, the a value has to be greater or less than 0, right? So what is a in this picture? It's negative 2. So does that mean it's opening up or down? It's opening down. So we're going to put it opens down because a equals negative 2, and that is less than 0. Now to determine the vertex, the cool thing about the vertex form is that you can look at it. It's kind of like the slope-intercept form. I can look at it and find the slope and the y-intercept. I can look at this and find the vertex. So the vertex, so this is a negative 3 here, so it's a positive 3 here. Positive 8 stays positive 8. And my axis of symmetry is x equals 3 because it always goes through the x value of your vertex. Determine your domain and your range. Remember, your domain is your x value, your range is your y values. So my domain, well, since this is a parabola and it's opening down, if you think about how that looks, it looks like this, right? And there's no parameter saying it cuts off here or like the piecewise functions. So since it's going on and on and on, the domain is going to be negative infinity to positive infinity. And our range is going to deal with our vertex. So since our graph is opening downward, there is a maximum. So that means the range is going to be between the maximum y value and what? Negative infinity. So you can have from this point everything down, but that's the maximum that we can have, so it's going to be 8. And since it can be an 8, we're going to leave brackets here. And we're going to come in from negative infinity because we can go up to that point. So you're going to read left to right. So the domain is left to right. And when you're writing your range, it's bottom to top. So you read from the bottom to the top. So basically, it's going to be little numbers to big number, little number to big number. Now, when we're talking about the function increasing and decreasing, remember you're looking at your x-axis intervals. So you're looking at your x-axis intervals. And we use parentheses on this, and we go left to right. So coming in from the left, we're increasing, we're coming in from negative infinity, and we're going to go to the x value of your vertex. And then, so remember, we're coming in from the negative side, and we're going to bump into that interval. And when we get to this point, what starts happening? We start going back down, okay? So we're coming from negative infinity, and we're going up. So we're increasing. We hit the vertex, and then we start going back down, so we're decreasing. So the decreasing is from 3 to negative infinity. Or sorry, from positive infinity. Because we're looking at the interval. So we're coming in from the x-axis, the x values to here, and then back down. So you're looking at your x intervals. So everything is about the x in your vertex. You move to the vertex, and once you get there, you come out of the vertex. Now determine the x-intercepts and the y-intercepts. So to find the y-intercepts, x has to be equal to 0. So all you have to do is take your function that's given and replace all of your x's with 0. So f of 0 is negative 2 times 0 minus 3 squared plus 8. So negative 2 times negative 3 squared plus 8. Negative 3 squared is 9, and 9 times negative 2 is negative 18. Negative 18 plus 8 is negative 10. So 0, negative 10 is my y-intercept. Now finding my x-intercepts, that's where we're going to use the last class lesson. We're either going to factor quadratic formula or complete the square or do the square root method, okay? So this is where your function has to be equal to 0. So we got negative 2 times x minus 3 squared plus 8 equals 0. So I am going to do the square root method. Since I have that x minus 3 squared, I want to do the square root method. So negative 2 x minus 3 squared equals negative 8. Then I'm going to divide by this negative 2. X minus 3 squared equals 4. And then I'm going to take the square root of both sides. X minus 3 equals plus or minus 2. So x is 3 plus 2 or 3 minus 2, because it's plus or minus 2. So that is 5 or 1. So 5, 0 and 1, 0. So your x-intercepts. So you could say x is 5, x is 1, or you could list them as points depending on what format it's asking. Either way. All right. And then to graph it, honestly, the easiest way is to use the points that you've got here. If you look at this, you've got a vertex. Make sure that I have a color we can see. So I've got a vertex. I've got 2 x-intercepts. I've got a y-intercept. And I can get another point if I need it. My axis of symmetry is 3, so I am going to put the axis of symmetry on here because I know that it needs to be symmetrical on both sides of that dotted line. So if I go to 3, and I just dot my line here, so x equals 3 is my axis of symmetry, and now I'm just going to plot the points and graph them. So 0, negative 10, so that's down here. 3, 8 was my vertex. And then I had a 1 and a 5. So I know if this is supposed to be symmetrical on both sides, then if it's 1, 2, 3 steps away, 1, 2, so the other point should be right there. So your picture should look something like that. Questions? All right. So example 2 should be on the back of the white paper. Okay. Mine's out of order too, so maybe that's what happened. I don't know. All right, so we're going to do it again. This time we'll go a little faster because now we know what to look for. Okay? So does it open up or down? So it opens up because A is 3 and that's greater than 0. The vertex, so since this is a positive 2 here, it's going to be negative 2 and that's negative 9. And my axis of symmetry is x equals negative 2. The domain is negative infinity to positive infinity. In our range, so since this is opening up, it has a minimum, and the very minimum value is negative 9. So we'll use the brackets there. So the axis of symmetry uses the x value of your vertex, and your range will use the y value of your vertex. Okay, so the axis of symmetry uses x value of your vertex, and the range uses the y value of vertex. So the vertex is good for something. All right, increasing and decreasing. So it is increasing, so we're looking, remember you're looking at your x. So it's increasing from negative 2 to positive infinity. It's decreasing from negative infinity to negative 2. So if you think about it's opening up, and this point right here is negative 2, negative 9. So coming in from the negative infinity, it's going down. And then once it gets to there, it starts coming back up to positive infinity. So coming in from negative infinity, going out to positive infinity. All right, now the long part is finding your intercepts because that's where you have to do math and not just look at a graph, right? So the y-intercepts are when x equals 0. So we got 3 times 0 plus 2 squared minus 9. So that's 3 times 4 minus 9, which is 3. So 0, 3 is my y-intercept. And then the x-intercepts are when the equation is actually equal to 0 itself. So I'm going to do the square root method again because of that parentheses with the square. So 3 times x plus 2 squared equals 9. Divide by 3. And then subtract 2. So we have to take the square root of both sides. Kind of skipped a step, did it all at once. Or this would have been x plus 2 equals plus or minus 3. I just did it all in my head real quick. So how am I supposed to plot negative 2 plus the square root of 3? Well, this is where you'll have to put it in the calculator to get the decimal so you can get an idea of where it belongs on the grid so you can graph it, okay? So x is negative 2 plus the square root of 3, and x is negative 2 minus the square root of 3. So this one is negative 3.73, and this one is negative 0.27. So I'm going to plot those two numbers on my x-axis. So negative 0.27 is going to be like right there. And 3.73 is going to be like right there. My y-intercept is 0.3. My vertex is negative 2, negative 9. So I know it's going to be something like this. And of course, not perfect, but close enough. And of course, if you do not have enough points, you can always grab a couple of numbers and just plug them in and do the math and get your couple of extra points if necessary. But hopefully, between your intercepts and your vertex, it'll give you a good enough idea of what your parabola should look like. And I'm going to go ahead and do my axis of symmetry through here so I don't accidentally forget, because it is part of your graph. All right. Now we have one in good old standard form. So this one is going to open up because a is equal to 1 and that is greater than 0. So our leading coefficient is a 1. Now to find your vertex, try not to make mistakes here. All right, so to find the vertex, the x value is negative b over 2a. So remember, this is ax squared plus bx plus c. So negative b over 2a. Well, b is my 2 and a is 1. So negative 2 over 2 is negative 1. And now to get the y value, you have to plug negative 1 back into your formula. So f of negative b over 2a, which is f of negative 1. So that means negative 1 squared plus 2 times negative 1 minus 8. So you're just plugging it back into the equation they gave you. So remember, you're finding all the information about this one graph. So negative 1 squared is 1. 2 times negative 1 is negative 2, and then minus 8. So, I'm sorry? So 1 minus 2 is negative 1, and negative 1 minus 8 is negative 9. So my vertex is negative 2, or sorry, negative 1, negative 9. Looking at the wrong thing. Negative 1, negative 9. So the axis of symmetry is x equals negative 1. So if you consider that this is opening up and our vertex is negative 1, negative 9, determine your domain and your range. Well, the domain, so our domain is negative infinity to positive infinity. The range, so remember, since the lowest point is negative 9, it's going to go up to positive infinity because I can go from here up. My increasing, so I'm coming, so you remember you're looking at your x. So I'm coming in from negative infinity and I'm bumping into negative 1. So negative infinity. Okay, so increasing. So increasing is looking at the x intervals. So we're coming in from the negative, we're bumping into negative 1. And then once we hit that negative 1, we're going back out. So actually I wrote that backwards. This is the decreasing. So we're decreasing, coming in, because we're coming in from this way and going down. And then we're going to increase and go from negative 1 to positive infinity. So I'm reading it left to right, and then I wrote it backwards. So we are decreasing, coming in from this way, bumping here, and then increasing from this point, going back out. All right. Now the fun part, finding our intercepts. The y-intercept is when x is 0. So just take the equation x squared plus 2x minus 8 and plug in zeros. 0 squared plus 2 times 0 minus 8 is just negative 8. So your y-intercept is negative 8. Your x-intercepts are the ones where we have to do some work because that means y is 0 this time. So we've got x squared plus 2x minus 8 equals 0. So we can complete the square. We can do a quadratic formula, or we can factor. I'm going to factor with the x because remember the shortcut that I showed y'all? If you factor this way, these numbers right here are your x-intercepts if you change their signs. So I'm leading in with a 1. I have a 2 in the bottom and a negative 8 here. So I know that 4 times 2 will give me 8. But I need one of them to be negative. So we're going to make the 4 a negative and the 2 a positive. Because negative 4, oh, no, I did that backwards. A positive 4 and a negative 2. As soon as I said it, I was like, hold up, that's not right. Positive 4 times negative 2 is negative 8. But when added, will give me the positive 2 that I need. So if you change their signs, then you get your x-intercepts. So negative 4, 0, 2, 0. Again, if they want, however they want you to display them. The x-intercept is negative 4 and 2. Negative 4, 0, 2, 0 is so I can graph them. So now I have all the points that are necessary to graph this. My axis of symmetry is at negative 1. So I'm going to go through, do my axis of symmetry here. And then I'm going to plot my points. I got negative 4, 0. I got 2, 0. I got 0, negative 8. And then my vertex was negative 1, negative 9. So it's going to look something like this. Again, the 4 points should be enough to get an idea of what your graph should look like. But if this is my axis of symmetry, if I'm one step away here, I would need to be one step away here. So that's one way to kind of get a better idea of what your graph should look like. All right, next example. This time we have a leading coefficient of -2. So this one opens down because A is -2 and that is less than 0. The vertex is -b over 2a. So -16 over 2 times -2. -16 over -4 is 4. So to find the y value, you're going to plug 4 into all of the x's. -2 times 4 squared plus 16 times 4 minus 32. So we got -2 times 16 plus 16 times 4 minus 32. -32 plus 64 minus 32. Well, -32 and -32 is -64, and -64 plus 64 is 0. So my vertex is 4, 0. My axis of symmetry is x equals 4. So this is opening down. So I'm just going to go ahead and draw myself a picture over here to the side with my vertex at 4, 0, so that I can get my domain and range, my increasing and decreasing. So the domain is -infinity to +infinity. And the range, remember the range is bottom to top, so that's -infinity to 4. Oh, not 4, 0. Good Lord. Just as I wrote it, I realized I wrote the wrong thing. We're looking at the y values, which is 0. All right, increasing and decreasing. So increasing and decreasing is looking at your x values. So I'm increasing coming in from the -infinity to 4. And then once I hit the 4, I am then going down. So back up. So coming in from the -infinity, I hit the 4, and then I start going down. So coming in from the negative, going out on the positive, left to right. And we are looking at the x intervals, so we're going to look at the x value of our vertex. Determine the intercepts when x is 0. So just replace the 0. Zeros are good because it makes everything cancel out. Goodbye, goodbye, -32. So we're not going to be able to plot that point because our graph doesn't go to -32. So we'll have to come up with our own. So now set it equal to 0. And the first thing I'm going to do is I'm going to get rid of that -2. So I'm going to divide both sides by -2 so that I can have a leading number of 1. So So that gives me x squared minus 8x plus 16. And then I can factor this out. Two numbers that multiply together to give me 16, but when added give me negative 8. Negative 4, negative 4. Change the sign. There is only going to be one x-intercept this time, because you've got x minus 4 times x minus 4. So now when you try to graph it, it may be a little more difficult because you don't have enough points. So our axis of symmetry goes through the vertex, which is 4, 0. So my x-intercepts, there's only one, which is the vertex. Well, that's not enough. I've got literally 1 point because the other one is the y-intercept, which I can't get to. So pick a number to the left of your axis of symmetry, pick a number to the right. I'm going to choose 2 and 6. So if x is 2, what is y? So I'm going to plug it in. So negative 2 times 2 squared and what I see here is 16 times 2 is 32, and 32 minus 32, those are going to cancel out. So negative 2 times 4 is negative 8. So 2 negative 8 is a point. Well, if I'm 2 steps away from my axis of symmetry, can I go 2 steps away on the other side since that is the middle? So 1, 2. So I don't have to do that again. I don't have to worry about the 6. So I can just get an idea of what this looks like that. All right, the last two, we don't have to do all of this. We're going to do some, we're going to apply it to some type of real world application where you're using these points to solve it. Last part. So if you are a manufacturer of a laser blaster on Mandalore, has found that when the unit price is P, so when your unit price is a certain number of dollars, you're going to make revenue. And it's going to be in the form of revenue of P equals negative 4P squared plus 4,000P. So that is the equation that's going to get you revenue. All right? What price should you have per unit to establish revenue? And what is the maximum revenue? All right, so think about what it's going to look like. So we're talking money. We're starting with nothing. We're going to go up to our maximum revenue, and then we're going to come back down. All right, so this is the P axis, and this is your revenue axis. So this is the cost per unit, and then your revenue, okay? We'll take your function, R of P equals negative 4P squared plus 4,000P. And what we want to know, if they're talking maximum revenue, that represents your vertex, because this graph is a parabola, and at the tippy top of your parabola is going to be your maximum revenue, right? So we need to find the vertex. We need to find the vertex. So the vertex is negative B over 2A. So negative 4,000 over 2 times negative 4. So negative 4,000 divided by negative 8 is 500. So remember, this is your X value. That's the cost per unit. So we're talking 500 per unit. So that's what you're going to charge per unit for your maximum revenue. Now, what is the maximum revenue? What is the revenue when your max price is 500? So now you're going to take the 500 and replace all the P's with 500. So our revenue at a unit price of 500 is -4 times 500 squared plus 4,000 times 500. And of course, we would plug this into the calculator. All right, we plug this into the calculator and you get 1,000,000. So to answer their question, which says, what unit price should be established for the blaster to maximize revenue? I would answer it as the max revenue is 1,000,000, and that occurs when the unit price is 500. So whatever you're selling for 500, you're gonna make $1,000,000 with that formula. All right, last one. So Princess Meridia, she shoots a warning arrow at her suitors. So she shoots it into the air at a speed of 64 feet per second from a castle window that's 48 feet above the ground. The height of the arrow is given by this function. So we've got the height with respect to time, -16t squared plus 64t plus 48, where t is the time in seconds. How long would it take for the arrow to hit the ground? So again, think about, you're not going to have anything except for in quadrant 1 because you cannot have negative time. So this is your time. And this is your the height. All right, we are starting at 48 feet. So the castle is 48 feet up here, and then you've got your little princess up here. And she's going to shoot an arrow at some fella down here on the ground. She's giving him a warning shot. All right? So I want to know when she fires this into the air and it comes back down, how long does it take for it to be on the ground? So you're looking for the x-intercept. All right? So you take the function, so -16t squared plus 64t plus 48 equals 0, because I want to know when it's on the ground. So for it to be on the ground, it's at 0 height, right? So let's plug in zeros. Actually, let's do this. We're not plugging in zeros. Back up. I just told you that wrong. We set it equal to 0. This is the last one. So if we're setting it equal to 0, then we're going to have to factor quadratic formula, complete the square, or do the square root method, right? But all of these numbers are divisible by -16. So always check to see if you can reduce it first. That way you're not dealing with such big numbers. So we get t squared minus 4t plus 3 equals 0. We can't factor this one because I cannot make 3 be a -4. And this is supposed to be a -2. I can tell it's the end of the day because I am tired. I am making too many mistakes. And y'all are tired too because you're not catching me. So a negative times a negative, positive, negative, positive, negative. So the first negative cancels out. I said, but I wrote, right?
You said -2, so I wrote negative.
What I wrote is correct.
Okay.
So divide all your numbers by -16. All right, now, since I cannot factor this because I cannot make -3 become a -4 no matter how I try to add or subtract it, so I'm going to do the square root method because that'll be the fastest way. So we got t squared minus 4t, and then we're going to move the 3 over. All right, I said square root method. All right, so t squared minus 4t plus a placeholder equals 3 plus a placeholder. So let's do completing the square instead. So what am I going to do next? I'm going to do my parentheses, and I got t minus. What number do I take half of?
4.
So half of 4 is 2, and 2 squared is 4. So 4 is my placeholder number. And then 3 plus 4 is 7. So now I can do the square root. So I get t minus 2 equals plus or minus the square root of 7. So again, we're trying to find out how long it's going to take to hit the ground. We're not going to say, oh, it's going to take 2 plus the square root of 7 seconds, because who's going to even know what that means? So plug it into your calculator. So you got 2 minus the square root of 7 and 2 plus the square root of 7. So negative 0.65. Can you have time that's negative? So this one is not going to work. This one, 2 plus the square root of 7, is going to be about 4.65 seconds. So when it says, how long does it take for the arrow to hit the ground in front of her suitor's feet? Time is 4.65 seconds. And that is all. I apologize for the mistake there and here and there, but we're done.